Hey Algebra 2 students. Today we're going to be going over just the complete unit circle and a few different things, few different skills that you need to know for that. Last week we did most of the unit circle. We wrote down the coordinates for most of our places here when we did all those different triangles. But this is the completed unit circle. It has all of the coordinates. It has, if you recall, the first coordinate is cosine, the second one is sine. It also has tangent out here, which is kind of helpful, okay? And that's just found by doing sine divided by cosine. But it's very helpful that it has all that. It has our degrees, which you guys wrote in. And it also has radians, which we're going to remember, like basically review how to convert between the two. Okay? But it has it all filled in, which is really nice. And again, remember that your three coordinate values are 1 over 2, root 2 over 2, and root 3 over 2. And this is the decimal value of those. Okay? Between, right here it's 0.5, 0.707, and 0.866. And when you look at all these, they're always in between 0 and 1 for the unit circle anyway. So, what we're going to do is we're going to practice how to convert, like I said, between radians and degrees. So for the first activity, you guys are going to be given this sheet right here. And I'm going to show you how to do 2 of these, and then you're going to do the rest. So remember what I told you. Use pi over 180 to convert from degrees to radians, and 180 over pi to convert from radians to degrees. So that's all we're doing. We're just going to convert between the two. So if I'm going from degrees to radians, remember it said to use pi over 180. So that's my conversion ratio. So pi over 180. So I'm multiplying 250 by pi over 180. That's what I'm doing. So the angle then, this should be, I'll fix that for you guys, angle in radians. Then we've got degrees over here, we'll have radians over here. So for our angle in radians, it'll be 250 over 1 basically times pi over 180. And again, you can basically just simplify this. So I know that both of these are divisible by 10, so I can at least cancel out the zeros there. If I divide that by 10, I get 25, and I divide that by 18, I get 180. Or sorry, if I divide that by 10, I get 180 or 18. You know what I mean? Divided by 10 gets rid of the 0. Anyway. So then, I guess there's really nothing else I can do. 25 only has a few factors. It's 5, basically, 1 and 25. And then that one has a decent amount of factors, but this one doesn't. So we can't simplify it anymore. So our final answer for that in radians ends up being 25 pi over 18. So that's what you have to do. Just multiply by the conversion ratio that you're supposed to use and then simplify it. So now I'm going to do this one. We're going to go the other way. So it says use 180 over pi to convert from radians to degrees. So on this one, I'm just going to write, for the conversion ratio, I'm going to write 180 over pi, because that's the one I have to use. So again, I multiply these two together. So I can kind of do that over here. I'll just show you all my work here. 180 over pi times 7 pi over 3. And again, these are really helpful when, let's say you can't find it on the unit circle. You might want to know how to convert, just in case you can't find that specific one on the unit circle. Some of these are not on the unit circle. So when you simplify this, you just have to see, okay, there's a pi on the top and the pi on the bottom. So those pi's cancel. And then I can reduce this a little bit too. I can divide this by 3 and this by 3. So 180 divided by 3 is actually 60. And 3 divided by 3 is 1. So now I have 60 times 7. 6 times 7 is 42, so this is 420 because it's a 60 times a 7. So 420, and the bottom is still just 1, so this is 420 degrees. So that's what you have to do for these. I just gave you 4 more. Do the exact same thing that I just did, just now using some different numbers. Also, okay, the next thing we want to do, you'll want to go to the Unit Circle Lab, Step 1, Module 1, I believe it's actually, it might be Module 2. It's Module 2, Step 1. And if you go there, there's a video that basically talks about the derivation for sine squared plus cosine squared equals 1. This is a property basically that you have, and it's related to the actual equation for the unit circle, which I have here for you. So just watch that video in the Hero Lab and write down what they have there. And then I'm going to show you how to do step 2 and check your learning. So step 2, this just uses your unit circle. So I'm going to show you one of these, and then maybe I can show you 2 of these. So for this one, pi over 4, where is that located? Well, you guys actually have seen this on your unit circle. So we have to find the sine value, which is given, cosine, and the quadrant. So we just look at our unit circle, and you'll have this. And I go, okay, there's 45 degrees. Pi over 4 is actually what it is. And remember, this first value is the cosine. The second value is the sine. Okay? And this is in the first quadrant. So if you actually, we can write this on here. I'll actually have this for you, for your quadrants. It's just like the coordinate plane. Okay? Where you have first quadrant, this is Roman numerals, second quadrant, third quadrant, and then this is fourth quadrant. Okay, so again, this one's the upper right area, so that's the first quadrant. And again, remember, when you have your points, and I'll write it over here, it's always cosine first, then sine. Okay? So again, look right here, square root of 2 over 2 and square root of 2 over 2. And remember, we're in quadrant 1, so that's what you want to put for this. Pi over 4, or 45 degrees, is root 2 over 2 for cosine and sine, and then it's in quadrant 1. Okay? We'll do one more. So 4 pi over 3, or 240 degrees. So let's look at that. So where do we find 4 pi over 3? Here it is. So 4 pi over 3 is this bottom left quadrant, okay? And if you look up here, it's 1, 2, 3, 4. It kind of looks like a C. 1, 2, 3, 4. So 3 is the quadrant that 4 pi over 3 is in. So I know to put a 3 for that quadrant. And then these are my values here, -1/2 and negative root 3 over 2. So remember, this is cosine, this is sine. So when I fill this in, okay, then I have to do, well, actually we already have one of them for us, -1/2, which was good, and then this one was negative root 3 over 2, okay? And then remember, this was the third quadrant, and so we can use Roman numerals, or we can use, you know, just regular numbers, doesn't matter. But yeah, that's how you do those. So now you're just going to have 2 more of those to do. Final thing, check your learning. So back up here, using that Pythagorean theorem that you will learn about in step 1. So here's this. Sine squared plus cosine squared equals 1. So what you have to do is just check to see, are these values, will they work for that property there? Now, this says here, below is a list of several coordinates, okay, and we're trying to use that property to determine if they're on the unit circle. If they end up being that the left side equals the right side, then you will get, like if you get something close to 1, like this, 0.99 or 0.98, we can treat it as 1, and that would be yes, it's on the unit circle. So what we can do is we'll try this one right here. So we just have to plug this in. So we take this and say 0.5 squared. That's what we're doing here, 0.500 or just 0.5 squared, plus 0.866 squared, and then we're going to just see if it equals 1. So again, we're doing number 1 here. Oops. Okay, here we go. So 0.5 squared plus 0.866 squared. And then if this is equal to 1, then that tells us yes, that point is on the unit circle. So we get 0.99956. Yes, that is definitely 1. That definitely rounds to 1. So yeah, since it's approximately 1, we're going to say yes, that point is on the unit circle. So you can just put it, yes next to that one. So what you have to do is make sure you do the rest of these and see if they're close. And then I'll just show you one thing here. When you plug this in, you have to make sure for the negative ones, just make sure you put parentheses around them on your calculator. For these, I didn't have to. You can kind of see that. I didn't put parentheses around them, but it'll be important when you have negatives. So make sure you use these as parentheses. So this one would be, trying to see if that equals 1. So you're just basically checking to see if it equals 1. So I'll do that one with you as well, just to show you how to put it in. So I do parentheses this time. Just be careful. You don't have to do it on the positive ones, but you definitely want to do it on the negative ones. So negative 0.992 is what that one was. And then we'll square it. We get 1.17, and now that's not close enough to 1. If it was like really, really close, that's different, but this is not equal to 1. So I'm going to say for this one, no. That point is not on the unit circle. So that's what you have to do. So finish those last couple, those last 3, and just work on the rest of the worksheet.